Alright, so in this section we'll look at solving systems of linear equations. Let's start with a simple question. Where do the two lines shown meet? The answer is pretty easy. You can look at this, eyeball it, and say it's right there. And that location is 2 on the x, 4 on the y. 2, 4. It's a good thing that this picture is small. I mean, if they met at, say, something like 100, 200, or 1,000, or if they didn't meet at a nice grid point, then this would be very hard to answer this question. But this simple problem where they meet at a nice grid point, numbers are small, we can look and answer. It's a pretty special point. 2, 4 is a solution to both lines. Okay, we can check this out. So the equations that these lines came from, one of the equations was y equals 3x minus 2, and the other equation was 5x minus 2y equals to 2. Right? So those are the two equations. So is 2, 4 going to work out in this? Well, let's put in 2 and 4 for x and y and see if they work. So x is 2, minus 2, y is 4, that's 6 minus 2, and that seems to work. How about in this one? Well, x is 2, y is 4, that's 10 minus 8, and indeed that seems to work. So 2, 4 is indeed a solution. Now you might be thinking to yourself, is that the only point? Well, let's take another one. Let's take this point right here. Right? That's clearly on the blue line, so that's the point 1, 1. Right? Is 1, 1 a solution? So let's check it out. So here's the question. Is 1, 1 a solution to both? The only way to answer that question is to check it out. So y equals 3x minus 2, and x is 1, y is 1, so 3 times 1, 1. So that indeed works, right? 3 minus 2, so that works. How about on the other one? So this time we have 5x, no, 5x. Oh my goodness. Let's try that again. 5x minus 2y equals to 2. So 5 times 1, 2 times 1. So 5 minus 2 equals to 2. 3 equals to 2. Clearly that doesn't work. So 1, 1 is not a solution. So this point 2, 4 is the only solution. Any other point is either not on the both lines, so if I choose a point over there, it's not on both, or it's on one and not the other. So 2, 4 is pretty special. So let's see if you can answer the following question. Find where x plus y equals minus 1 and y equals 2x minus 7 meet. Okay, so x plus y equals minus 1. What I'm going to do is I'm going to draw these lines now. Let me see if I can. Okay, so I'm going to take x plus y equals to minus 1 and draw it. I'm going to do this in, put it into slope intercept form. So I'm going to subtract an x over, and I'm going to have y equals minus x minus 1. So the slope on this, if you remember from your graphing times, is minus 1, and the y-intercept is 0 minus 1. So starting at this origin, go down to 0 minus 1 right there, and then I'm going to go down 1 and over 1. And you have to be really careful about drawing these, because if you don't draw this carefully, then your whole thing is going to be off. It looks easy enough to draw, but it turns out really difficult, especially if you're trying to do this by hand, which I'm trying to do, and I am no artist. So here is my best effort at drawing that line. So I'm going to do these in different colors. The second equation, of course, is y equals 2x minus 7. This is already in slope-intercept form. So the slope on this is 2 over 1, and the y-intercept is 0, negative 7. So again, starting at 0, 0, go down to 0, negative 7. This time I'm going to go up 2 over 1, up 2 over 1. Hey, look at that. So again, let's try and draw this very, very carefully. Like so. All right. And so it appears that they cross at 2, negative 3. 2, negative 3. All right, we can check. So let's check. Right? So it appears that they cross at 2, negative 3. Does that work in both? So the first equation is, so sticking to my color scheme here, x plus y equals negative 1. So I'll try 2, negative 3, 2 for x, negative 3 for y. So that appears to work. 2 minus 3 is negative 1. And let's do the other one. Y equals 2x minus 7. So 2 times x is 2, right? Y is negative 3, negative 3. That's 4 minus 7. 4 minus 7 is indeed negative 3. So that works. So 2, negative 3 is where they cross. Now, what we've been doing here is what's called solving systems of equations graphically, right? That's what this is called, solving a system of equations. So if you were told solve x plus y equals minus 1, y equals 2x minus 7. This is the two equations that we did in this above equation. Solve. It's usually sometimes written like this, on the two equations, one on top of the other. If this was your question, then the answer to this question would be 2, negative 3. This is where the answer is the point where they cross. That's the answer, right? So one way in which we can find this answer, of course, is what we've been doing here, graphing them and looking for the place where they cross. Of course, there are all kinds of challenges to doing it this way. One is being able to draw this picture super accurately, and the second is hoping that they cross that nice place, which they may not, or they're small enough for us to actually draw. But bottom line is, when you solve a system of equations, you're finding where they cross. Now, this method of drawing and finding where they cross is called the graphical method, right? You should only use this if the problem says solve graphically, okay? Solve graphically. So solve the system of equations graphically, then you can draw it and find the other one, the point where they cross. Now, if they don't say that, we're going to use algebraic methods to find this. And that we'll take a look at in future sections. But I hope this is clear. Solving a system of equations is essentially finding where they cross.